depending on what purposes you're using R for, you may want to deal with data containing dates and times. And now we'll look at how R handles dates and times, and dates in particular, I would say. And if you use this command, Sys.Date, with a capital S and capital D, then you get the current date, as you can see, year, month, and the day. And this looks sort of like a character string, but it's not. If you ask for the class of this object, then R tells you that it's actually a date. So that's the class of this object. And it's treated differently compared to character strings. And the date that you got here, that's in our standard format. And the standard format is actually the same that we commonly use in Sweden, so it's quite easy for Swedes to use R. It's year in 4 digits, it's month, and it's the day, and they are separated by dashes. But of course you could get data from elsewhere where the dates have a different format, and then you have to transform them into the native R date format. And in this case we have data containing, as you can see, dates written as month, day, year, and separated by slashes. And if you want to convert this into dates that R can deal with, then you have to use the command as.Date. And in this case it's small a with a capital D, so it's not always the same. And the first argument here is the object containing the dates, in this case the object dates, which we define here, followed by a definition of the format for these dates. In this case it's written like this, and if we look at the result, we get a vector containing dates in R's native format. Of course, not all dates are formatted this way, and if you get the data set with a particular format of the dates, then you'll have to look into the help text of strip_time, which shows all available format alternatives so that you can tailor it to your specific needs. Strip_time is actually a date format as well, but unlike date, it also treats time, so it could contain both the date and the time, much like in Excel, where you have the date format, which could contain time as well. And we won't go into that any further, but if you need to put these in the same object, then strip_time might be a better choice. If you ask R to convert the dates into numeric values using as_numeric, then you get this. Numeric values in the range of 10 to 11,000 in this case, or 12,000. And what this is the number of days that have elapsed between R's index date and the dates stored in the dates_to object. And the index date in R, that's when everything starts day 0, happens to be 1970, 1st of January 1970. And this is not the same in all systems. In Excel, for example, it's January the 1st, 1900 instead. So you get different numbers when you perform this in Excel. And if you try to subtract dates, in this example, we take the dates_to object and then we subtract another date, 1900, January 1st, 1900. Then we get a time difference in days. And R actually tells us what this is, that it is a time difference. So 36,216, that's the number of days that have elapsed from or between January the 1st, 1900 and the first date stored in dates_to. And if you use the command weekdays, small w, then you get this, and that might be a bit surprising. As you can see, you get lördag, onsdag, tisdag, måndag, fredag in this case, and that's the weekdays, the names of the weekdays in Swedish. And this is nothing that you can change in R itself, but it depends on the settings in your operating system, in Windows in my case. And another possibility is to use something called POSIX-CT. It's a date format that accepts not only date and time, but it also deals with time zones if you have data containing time zones. But usually date is actually sufficient.